right, so today is October 5th. And we're looking at section 2-4. And this is probably about day 2 because I think we've already done day 1. We're going to take a specific look at trig functions with chain rule. Trig functions with chain rule. All right, so the first thing we have to do to be able to do any of these is, all right, go back over all of those trig formulas that you supposedly already know, right? You memorized that the derivative of sine was cosine. You memorize the derivative of cosine was negative sine. So none of those are going to change, except we're going to look at those formulas in terms of u. We're going to put a u in the formula so we see the chain rule. So we are going to rewrite all of them. Okay, so let's say we had a d dx, and yes, I am taking the derivative with respect to x, all right, of a sine u. And then let's over here write u is a function of x. All right, so in every one of these formulas, our u is a function of x. I am doing d dx of sine u. Okay, and we know this is going to be, but it's going to be cosine of u times u prime, so times the chain. All right, so cosine u, that part of it stays the same, sine to cosine. All right, cosine u times the chain. This is the chain, okay? So d dx of cosine u, where u is a function of x. All right, the derivative part that we've already memorized stays the same. So it's minus sine u, but then you've got to remember to take that times u prime. And actually, I don't want that parentheses where I put it on that. I would like the parentheses to go on around the inside. So minus sine u. There you go. Just being picky about where I put the parentheses. All right, then we've got a d dx of tangent u, where u is a function of x. All right, what one is that one? What's the derivative of tangent? Secant squared. So we'll have a secant squared u, all right, times the chain u prime. Okay, d dx. Let's see, we should know secant. Secant u, where u is a function of x. Okay, so derivative of secant is, yeah, secant tangent. So secant u tangent u, because that's the formula itself, okay, and then times the chain. Okay, and then we've got 3 more. I'll put 1 more down here on the bottom and then go to the next column, d dx. Actually, we don't have that many left. We need cotangent and cosecant. So cotangent u. And what else was the cosecant squared? Negative. So negative cosecant squared u times the chain. Okay, last one because I'm running out of room. I'll do it over here. d dx of cosecant u. Again, where u is a function of x. So that derivative is negative cosecant cotangent. So negative cosecant u, cotangent u, and then u prime. So the next time we do a memorization quiz, you're going to have to pay attention to the difference in the way I write the initial problem. If I do d dx sine x, you're going to give me cosine x. But if I do d dx sine u, that means u is a function of x, you're going to give me cosine u prime. Because when I do it with u's, where u is a function of x, it's trying to indicate to you where that chain is, to remind you that the chain is. If I put a plain x here, then it'll be a plain x. Okay, so that'll be the difference on the memorization, please. Okay. All right, now we already know the idea of trig functions, doing derivatives of trig functions, and we did chain with polynomial curves. So now we're just going to do trig functions that have chain rule in them. Okay, and then we'll start kind of minor, but then we're going to, in the examples that we do in here, we're going to kind of go really fast and get some really complicated ones to start with. Okay, so you got to be able to keep track of how many chains you're going to do. All right, so let's say we've got f of x equals cosine x squared plus 1. All right, so you can think of this as cosine of u, where this whole thing is u, in other words, a function of x. Okay, so this is the inside, cosine is the outside. When we have chain, we've got an inside, x squared plus 1, we've got the outside, which is cosine. All right, so this is a relatively simple one. If we remember chain from last week, we did the derivative of the outside function. So derivative of cosine is negative sine. And then we left the inside alone. You leave the inside alone times the chain, ddx, of the inside. All right, on this, we're going to use ddx notation on the whole homework assignment. Okay, we're going to use the ddx in the whole homework assignment. Okay, so we're going to leave this first part alone, so minus sine x squared plus 1. All right, now derivative here, just a nice little 2x. Okay, so this one's a relatively simple one, right? Pull that 2x out in front with the negative, minus 2x sine x squared plus 1. Okay, so that one would have been an easy, straightforward, one chain, nice little cosine, not a problem, right? Okay. Let's do another couple other ones that are going to be straightforward, easy before we hit some of the harder ones. All right, let's suppose I give you f of x is equal to a sine squared x. Every time you've got a trig function and it's being squared and they write the 2 here, I would really seriously rewrite sine x to the second power. Write it so that you can clearly see what the base is and what's being squared. Okay, especially when they change this to something other than just an x. When they start saying sine squared of 2x to the third plus 5x or something like that, and this becomes a more complicated function, you definitely need to rewrite like this. All right, now I can start my derivative so I can show the f prime notation. Okay, this is going to be outside function is something squared, inside function is sine x. Okay, so pull the 2 down in front, sine x. I would go ahead and write it to the first power, because if that was any other exponent other than 2, I would have to remember to make that go down by 1. All right, leave the inside alone. Pull the 2 down, leave the inside alone, subtract the 1 on the exponent, times the derivative of the inside, which is derivative of sine x. Okay, so like I said, again, pretty straightforward. So 2 sine x, and then derivative of sine is cosine. So cosine. And then I can just write it together, leave that dot out. You can put the dot in if you're doing your work, that's fine, but then write a final answer nice and clean like that. All right, and something being said when you see this typed, all right, you'll see parentheses like in Math Excel and stuff, you'll see parentheses around that. I usually leave them out just when I handwrite, okay, but they really do go there. All right, let's do, how about let's let you do one by yourself. Let's do find f of x equals sine x squared. Now again, I'm going to write it like sine x squared. The book will probably put the set of parentheses around that, showing you that it's not the whole entire quantity being squared, it's just x being squared. All right, so I'm going to pause. You do that one on your own, since that's probably going to be our last easy one. We're going to beef it up after this one. Okay, so in the room I froze it. In the video I can't freeze it. All right, so answer. Yep, 2x cosine x squared. Okay, so again, relatively simple one, straightforward. Okay, so I figure I'll let you try one simple one by yourself before we move up to the more challenging ones. Okay, and of the ones I've done so far, what have we had? We've had sine and cosine, and those are the only ones. Those are the most common ones. Okay, however, you got to be able to do it with all the others. Okay, so let's actually beat this up quite a bit here. All right, let's take a look at, say, an f of x is equal to, say, a cosecant to the third of x to the fifth. Cosecant to the third, x to the fifth. All right, so first of all, it's a cosecant, so it's not just your sine or cosine. All right, it is to the third power. All right, before you even start, you've got that exponent 3 right there in the middle of it. Okay, rewrite it so that you see cosecant x to the fifth raised to the third power. Okay, I would definitely rewrite like that every time because it's going to let you see things a whole lot better. Okay, now we clearly have an outside function, something being raised to the third. We have an inside function. Now let's talk about that inside function. It's cosecant x to the fifth. What kind of function is that? It's got a name, starts with a C. This inside function right here is a composite function because it also has an outside and an inside. I've got something being raised to the third power. My something on the inside is a composite function because it also has an outside cosecant and an inside. So this tells you that you're going to have to do more than one chain. Okay, so I'm going to start with f prime of x because I'm starting my derivative. I'm going to work with the first outside function and inside function. So my outside function is to the third power. So I'm going to pull that 3 down in front. I'm going to leave the inside alone. So cosecant x to the fifth is going to be left alone. I'm going to subtract 1 from the exponent because that's power rule, times the derivative of the inside, d dx, cosecant x to the fifth. So I pulled the 3 down. I subtracted 1 there. I left the inside alone. I'm going to take the derivative of the inside. All right, now taking a look at this right here, I have another composite function inside, outside function. So again, I've got to do chain again on this. So I'm going to leave my 3 cosecant x to the fifth, and that can be square brackets, it can be curvy brackets, it doesn't make any difference. I'm going back and forth because it doesn't make any difference. All right, now you take the derivative of the outside function. What's derivative of cosecant? And with the negative, don't forget negative. So it's negative cosecant cotangent x to the fifth. All right, so there's the derivative of my outside function, leaving the inside alone, times the chain d dx of x to the fifth. Okay, that one now is just a plain power rule, no more composite function, so that'll be my last derivative. Okay, so 3 cosecant x to the fifth squared times a negative cosecant x to the fifth cotangent x to the fifth, and then times derivative. My last derivative here is going to be a straight derivative, 5x to the fourth. Okay, so let's pull out this 3, the negative, and the 5x to the fourth, because those are all kind of coefficients. Let's pull those all out in the front. So we'll have a negative 15 x to the fourth. All right, now, do I have some like terms on my trig functions? Yeah. Cosecant x to the fifth, cosecant x to the fifth. All right, well, what? There's 2 of them here. Technically, there's 1 of them there. So how many do I have total? 3 of them. And then let's go ahead and put it back on the inside like that notation. So cosecant to the third x to the fifth And then that leaves the cotangent x to the 5th. You got to show every step. You need to show every chain. And you got to be organized. Okay. But more challenging just because, number one, two chains, and it was a cosecant instead of just a straight sine or cosine function. Yep. Yeah, it could be. I mean, I honestly, I don't know what's on the homework. Most of my examples are just straight functions, so no product and quotient rule yet, but there will be. You will put product rule, quotient rule with these. Yeah, it's coming. All right, let's take a look at a tangent one. We haven't done many tangent derivatives. So let's say we've got f of x is equal to the square root of tangent of 2x to the 5th. So hopefully you can kind of get a feel for this before you even start. Do I have three functions here? What's the most outside function? X to the 1/2 or the square root. All right, what's the middle function? The tangent. And what's the most inside part? 2x to the 5th. Okay, so that tells you you're going to do chain more than once. All right, so first step, rewrite it so I've got the 1/2 up at the top. So tangent 2x to the 5th, and then rewrite that so you've got a 1/2 up there so that you can see it. Okay, now I can start my derivative. I'm going to do the power rule first on that 1/2. I'm going to pull the 1/2 down. I'm going to leave the inside alone. So tangent 2x to the 5th. I'm going to remember to subtract 1. So when I subtract 1, I get a negative 1/2. And then times the chain times the derivative of that inside function. Inside function is tangent of 2x to the 5th. And then you look at this and you realize you have another composite function. You have an outside and an inside, so that means I got to do chain again. You're going to keep the 1/2. You're going to keep the tangent 2x to the 5th. You're going to keep the negative 1/2. Okay, now derivative of tangent is secant squared. So you take the derivative of the outside function, which is secant squared, leave the inside function alone, times the derivative of the inside function. And then when you get down here, you realize, oh, hey, that's just a plain nice little power rule. No more chains. You're actually done at that point. So then you go do that last derivative, keeping everything else the same. 1/2 tangent of 2x to the 5th to the negative 1/2. A secant squared 2x to the 5th. Let's see, derivative here is going to be 10x to the 4th. Okay, now you got to take your answer and then start doing some manipulation. Okay, simplifying, that sort of thing. I got a 10 here in the top. I've got a 2 here in the bottom. So that means I can, 2 goes into 10 5 times, 2 goes into 2 1 time. So that goes away. All right, then that means this right here has got a negative exponent. So that goes to the bottom. Everything else is in the top. This is the only thing that goes to the bottom. All right, when I move it to the bottom, let's go ahead and rewrite it as a square root, right? So square root of tangent of 2x to the 5th. In my numerator then, I've got the 5x to the 4th. Let's pull that out in front. And then the secant squared 2x to the 5th. Okay, not too bad. They're doable. Just multiple chains, that's all. Okay. All right, about ready to try one on your own? Try one on our own. All right, let me give you a cotangent to the third of a 2x to the fifth plus a 1. Go ahead and try that one on your own. Rewrite the function as a power raised to something raised to the third power, and then go from there. Okay, here we go. I already had it worked out, so it'll say. So, negative 30x to the fourth. Cotangent squared over 2x to the fifth plus 1. Cosecant squared over 2x to the fifth plus 1. All right, anybody get it right? Yay, we have people get it right. That right there? Yeah, yeah. Okay, but you ought to be able to, if you are following and doing work like I am and showing the DDX notation, your lines should correspond. So you ought to be able to real easily, like you said, you pulled down the 2, you forgot. Like you ought to be able to see where the mistake is. Yeah, Maya. Like you've got a bracket right here. All the way down. Yeah, because what is this? This technically is 3 things being multiplied together, and we can multiply things in any order and still have the same answer. So yes, you can have an extra set of brackets in there. All right, anybody? Yeah, the negative, you definitely don't want to drop the negative there, but oh, kind of drop it squared. Yes, and then it would be right. Yeah, so having all those trig derivatives memorized is definitely an important thing here. Okay, so we'll put this one here and put that piece of paper there. All right, so let's do for our last one, let's do a really long one here. Okay, so, and we'll do it together. I won't make you do it by yourself. Let's go f of x is equal to, let's do a 2 secant squared cotangent of 3x to the fifth. So we're definitely going to have lots of chains in this. Okay, you should see composite. You've got the most inside parts of 3x to the fifth, then a layer out is cotangent, another layer out is secant, another layer out is squared. So I am going to pull that 2 up just so I can see it a little bit easier. So 2 secant cotangent 3x to the fifth. And then I'm going to go ahead and put those square brackets in and make that to the second power so I can really clearly see that. So I've got something being raised to the second power. I have a secant function, I have a cotangent function, and keep going deeper inside that 3x to the fifth. All right, so I'm going to have lots of chains. Okay, we're going to do one chain at a time. All right, so f prime of x. All right, so now before I start writing here, obviously we're going to have to take care of this power rule, right? So we're going to pull that down in front. I've already got a 2 there. So 2 times 2 is going to put a 4 out there in front. I'm going to leave the inside alone. So secant cotangent 3x to the fifth. And then to the first power, because I subtract 1. So I would get in the habit of, even when it's the first power, write it there, because when it's something other than a 2, you got to remember to put it there. All right, times the derivative of all of that inside function. So ddx of the secant cotangent 3x to the fifth. The derivative of all of that. All right, which more chains? Okay, so the 4 square bracket secant cotangent 3x to the fifth stays put. All right, now the most outside part of this function is secant, right? Because this is all the inside. So the derivative of the outside, leave the inside alone. Derivative of secant is secant tangent Okay, so secant, leave the inside alone. Tangent, leave the inside alone. Oh, why do I put a equal sign in there? Let's make that a dot. Okay. So secant, leave the inside alone. Tangent, leave the inside alone. And then times the derivative of that inside, dx, cotangent, 3x to the fifth. Okay, now am I going to have another chain? I'm still going to have one more chain because I got an inside and outside. So I have another chain right there. Okay, definitely had a chain right there. Okay, so everything stays the same. I'm going to move over here to the left because I'm going to run out of room. So 4, square bracket, secant, cotangent of 3x to the fifth times secant, cotangent of 3x to the fifth, tangent, cotangent, 3x to the fifth. All right, now I'm ready for the derivative. We take the derivative of the outside function, leave the inside alone. Derivative of cotangent is, do we have that one memorized? Negative cosecant squared. So negative cosecant squared. Derivative of the outside, leave the inside alone, times my last chain, the derivative of 3x to the fifth. That's the last one. Okay, so 4. And technically, I could drop those square brackets. It's getting a little tacky. So secant, cotangent, 3x to the fifth. I've got another secant, cotangent, 3x to the fifth, tangent, cotangent, 3x to the fifth, minus cosecant squared, 3x to the fifth. Now that derivative on the end, 15, x to the fourth. Okay, now let's pull out in front. I'm going to have a 15x to the fourth. I'm going to have a negative. I'm going to have a 4. So we're going to pull all of that out. What is that going to be, like a negative 60 x to the fourth? Okay, now do I have any like terms? Yep, secant cotangent of 3x to the fifth, secant cotangent 3x to the fifth. All right, so in other words, I've got 2 of those, right? So let's write it with a squared. So secant squared of cotangent 3x to the fifth. All right, then I have one tangent function and I have one cosecant squared. So tangent of a cotangent of a 3x to the fifth. And then I've got the cosecant squared of the 3x to the fifth. My hand does cramp. That's an awful lot of work. Yes. Oh, right. Yeah. No, you didn't know. No. You might even, you'll probably be down to 1 column. Yeah, because it's going to go so far across the paper that. Now, I don't know that your homework is going to be this long. All right, but I have a tendency to do just easy problems in the lecture, and then the homework seems to be a whole lot harder. All right, so I thought, oh, let's just do some long ones in class to make them a little bit harder. All right, so then if these are really, really hard, and then maybe you'll only have easy to medium ones in the homework, hopefully. I don't know. I haven't looked at it. It's been a long time. All right, so